slides we are going to cover the presentation topics covered in this presentation about whenever the pipes are in series and parallel. What about the expression for series pipe arrangement, expression for parallel pipe arrangement, and about problems on parallel pipe arrangement and problems on series pipe arrangement. We are going to discuss about these 4 topics in this presentation. First, whenever the connected in series, the pipe is called as compound pipe. Pipes when are connected in series, both the pipes. The pipes are called as compound pipes, are defined as the pipes having different lengths and different diameters connected end by end. End by end nothing but a series from a pipeline shown in the figure. Look at the figure. Now this is a figure, 2 tanks which are connected by 3 pipes. Length of first pipe is L1, D1 is the diameter of pipe 1, F1 is the friction factor of pipe 1. L2 is the length of pipe 2, D2 is the diameter of pipe 2, F2 is the friction factor of F2. L3 is the length of pipe 3, B3 is the diameter of pipe 3, B3 is the velocity of flow at pipe 3, F3 is the friction factor. B. Now H is called as head between the 2 tanks. There may be loss. Now this head is not equal to this head. Why? Because there may be a loss in the friction. You have to calculate how much loss there may be occur in the friction. That may be, you have to find out the expression whenever the pipes are connecting. Let L1, L2, L3 are the length of pipes 1, 2, 3 respectively. D1, D2, D3 are the diameter of pipes 1, 2, 3 respectively. V1, V2, V3 are the velocities of flows from 1 to 3 respectively. F1, F2, F3 are the coefficient of frictions for pipes 1 to 3. H is the difference between the water level between the 2 tanks. Now the discharge is passing to the pipe is same. Formula is, in order to find out the discharge using the continuity equation, Q is equal to A1 V1, that is equal to A2 V2, that is equal to A3 V3. Next, if minor losses are neglected, there may be not considered minor losses, then the above equation becomes nothing but an Darcy-Weisbach equation. H is equals to 4F1 L1 V1 square divided by D1 into 2G, 4F2 L2 V2 square D2 multiplied 2G. Similarly, third pipe, 4F3 L3 V3 square D3 multiplied 2G. If the coefficient of friction is same for all pipes, if the coefficient of friction is same, F1 is equals to F2 is equals to F3. Now that remains here. I am substituting in place of F1, F2, F3, F. Now we get H is equals to 4F by 2G, L1 V1 square by D1, L2 V2 square by D2, L3 V3 square by D3. Now that is the expression for whenever the pipes are connected. Next, pipes are connected in parallel, those pipes are called as equivalent pipes. Whenever the pipes are connected in series, those pipes are called compound pipes. Now what is meant by equivalent pipe? Equivalent pipe is nothing but the pipe of uniform diameter having head loss and discharge to the loss of head and the discharge of a compound pipe. Loss of head in a compound pipe consisting of several pipes having different length and diameter. That means the uniform diameter head loss is always equal to head loss in and discharge of a compound pipe consisting of several lengths and diameters. That means instead of compound pipe we are using only single pipe. That pipe is called as equivalent pipe. Now uniform diameter of equivalent pipe is called as equivalent size of pipe. Now if the length of equivalent pipe is equal to sum of the length of compound pipe consisting of different pipes. Let L1 is the length of pipe 1, T1 is the diameter of pipe 1, L2 is the length of pipe 2, D2 is the diameter of pipe 2, L3 is the length of pipe 3 and D3 is the diameter of pipe 3, H is the head loss due to friction and L is the length of equivalent pipe as well as D is the diameter of equivalent pipe. Now all this has been replaced by single pipe L and D. Now then the equation becomes L is equals to L1 plus L2 plus L3. Now total head loss in compound pipe neglecting the minor losses, only friction losses are there. Now we know that friction losses HF is equals to 4F L1 V1 square by nothing but a Darcy-Weisbach equation, D1 into 2G, 4F2 L2 V2 square plus 2 into 2G plus 4F L3 V3 square D3 into 2G, assuming F1 is equals to F2 is equals to F. Discharge Q is equals to A1 V1, that is equals to A2 V2, that is equals to A2 V3. You know A1 is nothing but pi by 4 D square. From that V1 is equals to 4Q divided by pi D1 square. V2 is equals to 4Q divided by pi D2 square. V3 is equals to 4Q divided by pi D3 square. Now substituting these values of equation H, we get H is equals to 4F1 L1. Now in place of V1 square, 4Q divided by pi D1 square whole square divided by D1 into 2G. 4F2 L2 multiplied with 4Q divided by pi D2 square D2 into 2G. 4F3 L3 multiplied with 4Q divided by pi D3 square D3 into 2G. Now H is equals to by taking 4 into 16 F cube pi square into 2G multiplied by L1 by D1 power 5, L2 for D2 power 5, L3 D3 power 5. Head loss in equivalent pipe is equals to, which is equals to 4F LV square by 2GD. You know that equation E is equals to Q by A, nothing but an continuity equation. Q is equals to pi by 4D square. Now that from that we get H is equals to 4F in place of V we write as 4Q divided by pi D square whole square multiplied with 2 into 2G. 2G into D. Now it is 4 into 16 F Q square by 2G multiplied with L by D power 5. Head loss in component pipe and equivalent pipe is some equating the equations. This is the component pipe and this is the equivalent pipe. Now by cancellation this will be constant. The cancellation all remains same. Now remains L1 plus D1 power 5 plus L2 plus D2 power 5 plus L3 plus D3 power 5 is equals to L divided by D power 5. Now we know that this equation is called as Euclid's equation. Now in order to find out this equation, L is equals to L1 plus L2 plus L3 and where D1 and D2 and D3 are known. This is about whenever the pipes are in series and parallel connection, the expression for head loss due to friction, the expression for head loss whenever the pipes are connected in series, the expression for head loss whenever the pipes are connected in parallel. And the next coming slide is about the problems on compound pipes as well as problems on